Hello, my name is Adrian Hornsby and I'm part of the Technical Evangelist team at AWS, and today we're going to talk about operational excellence. So what is operational excellence? Well, before trying to answer that question, I want to point out that when your whole business depends on technology, which is the case for Amazon and AWS, well, operational excellence is critical. And that was true when Amazon first launched in 1995 and only sold books. If the online bookstore had an outage and was down, it was like if it would lock its door. And since Amazon already had customers from all over the world, there was simply no appropriate time to close the front doors. So being a successful technology company requires operational excellence. But what is OE, and especially how do we move towards operational excellence? Back in the early days, systems running the Amazon.com retail site were relatively straightforward. There's not maybe as simple as on this slide, but it was the essence of it. There was a front page, there were web servers, and a backend. And a database. And of course, there were tools to access the different data for the database, tools for fulfillment centers, for customer services, and things like this. So this everything shared architecture was not ideal, and Amazon quickly ran into scalability, but also innovation issue. This monolithic was really slowing teams down. And the long delays between deployments, testing and release to productions were common issues. It was really a challenge to deliver value for the customers. In other words, it was unacceptable. So Amazon invested heavily in breaking this monolith and decoupling the different components of the architecture to form something called service-oriented architecture. But that was not all. Amazon also made sure that each service was operated independently by a separate team that would own and operate that service. By doing so, it quickly found ways to innovate and support hundreds of millions of active customers on an architecture comprised of thousands of different services. So you probably would be interested in seeing an architectural diagram, but really it wouldn't make much sense. So instead, I'm going to show you this diagram, which is a service dependency diagram, where distinct services are represented outside of the circle. And the strong clustering arc that represent the dependency on the retail website. And as you can see, is pretty massive. So let's be honest. What is operational excellence? Well, it's hard to define really. However, there's one thing for sure. It's not a list of things you do or checkbox that you check out. Instead, there's a very good definition from Will Durant. And no, it's not Aristotle that said that. Indeed, operational excellence is more of a habit. It's something you repeatedly do. And it's a philosophy, it's a mindset, one that embraces problem solving, that ensure customers are happy, one that values continuous improvement, one that values exceeding goals. It's also a way to anticipate problems before they happen and a way to effectively respond to issues. For Amazon, it also means doing all that at significant scale, where significant means thousands of people around the globe and millions of servers. So maybe a better question would be, what does a technology organization, how does a technology organization move towards operational excellence? So in my view, it takes three essential interconnecting elements to operate the technology we built. The first is the right culture. The second is the right tools. And third, a complete process. So let's start with culture. Amazon culture is probably best understood by examining their leadership principles. They are the DNA of the company. They have been actually a revelation for me since I joined AWS. Unlike most companies I've worked with, the leadership principles aren't just inspirational hanging walls things. We use leadership principles every day when we interact with customers, when we discuss new ideas, when we discuss the best way to patch a server, or even hiring people. They're called leadership principles, but they apply to everyone equally, whether it's Jeff Bezos or a software developer just hired out of college. And that's one of the things that makes Amazon peculiar. All 14 of those leadership principles are actually very important to operational excellence, but in my opinion, few hit the nail on the head. Let me address the most obvious one first, and I'll touch on the others later. Customer obsession is arguably the keystone of the entire company. So much that it's actually the focal point of the company vision statement to be the Earth's most customer-centric company. Customer obsession is much more than customer satisfaction or customer happiness. It's a philosophy about doing what is right for the customer first and then working backward. To illustrate the importance of customer obsession related to operational excellence, I want to explain to you the Amazon flywheel. First, it's important to realize that customer experience is critical. That's where everything starts. As customer experience improves, it naturally drives more traffic to the Amazon.com website. As more people use the Amazon.com website, it attracts sellers. And as more sellers provide naturally greater selections of goods, it also increases sales, which means Amazon can lower its cost structure and reduce price for the customers. Once the flywheel starts, it's a snowball effect. People often think that innovation is about discovering new things, but it's essential to realize that innovating across existing dimensions is as important for customers as finding new things. Things like lowering price, wider selections of product, fast delivery, and of course, convenience. For AWS, the dimension important for customers and you in particular are directly related to operational excellence, and they are scale, reliability, security, performance, ease of use, and of course, pricing. Amazonians genuinely obsess over customer and working backward from them to help us improve and get feedback. In the early days of AWS, one person in particular called Low Flying Hawk really regularly suggested features in forums, and the AWS team began to really look forward to feedbacks from the Low Flying Hawk. So much so that during the meetings, people would say, what would Low Flying Hawk say? So the funny and peculiar thing about the Low Flying Hawk is it didn't spend a considerable amount of money on AWS back then, only $3 a month. But it didn't matter because this person input was very valued. It was so valued that we actually named a building after its alias. Another highly relevant part of our DNA is, of course, ownership. And that a culture of ownership is important to operational excellence should come to no surprise. Think about when you rent a car versus if you own your own. Think how you would react if you would see a crack in the foundation of your house versus if you would see it in a hotel or a rented house. So while many organizations organize themselves in functional silos separating operations and engineering, Amazon believes that customer-focused organizational models where all the function lives under one roof and are focused on the single customer need gets the best results. Each service is owned and operated by a team called Two Pizza Team, since they're rarely bigger than 8 to 12, 14 people. And this team builds, deploy, maintain, and operate the service. Yes, you hear me correctly. Build, deploy, maintain, and operate. They do everything. But as you can see on the slide, they are not responsible for building the tools. For that, AWS has a dedicated team, and for very good reason. We want to have consistency. Amazon has a strong culture of ownership, and ownership extends to operating software in production. We don't believe in throwing it over the wall. That means developers get to see how their code works and behaves in production. And one of the benefits of having developers seeing the code in production is they have immediate insight into what could possibly go wrong. While many companies are focused on tearing down this wall of confusion between engineering and development and operation, it's a movement known as DevOps transformation. Amazon never had to do that because we never had a wall to begin with. I'll come back into the culture in a bit, but now let's talk about the tools. There are, of course, a broad set of tools needed to operate in the cloud, and the essential categories are on the slides. Test automation, configuration management, software development, monitoring and visualization, reporting, change, incident management, so on and so forth. To understand the importance of tools, I want to dive deep into software development and how it impacted Amazon. So as mentioned earlier, the architecture running the Amazon bookstore back then was relatively simple and monolithic. When you're working with the monolith and you try pushing chains through the shared release pipeline, it causes friction. First, all the teams have to coordinate changes to avoid breaking everyone else. So if you upgrade a library, if you do a patch, if you want to improve security or do performance tests, everything requires the blessing of all the other teams. And that leads to situations where you have so-called merge or freeze Fridays. And sometimes even worse, it can be freeze merge weeks. Everything is shared. So for every change, you need to rebuild the whole application, run all the tests, and redeploy all the components. And that creates tremendous amount of extra work. So Amazon had a central team dedicated for that, and it was called Houston. The sole purpose of that team was to deploy this monolith application in production. And it was called Houston because it was quite risky back then, and an application is deployed would often be followed by Houston, we have a problem. So the second phase of the deployment was to copy the different command line tools into the central NFS server. And that was pretty convenient until the NFS server failed and took the whole operation down. So the command line tool ranged from server administration to customer services. Below is a command tool run by an operator if you want to do a refund. Since everything was shared, the customer operator had to run those commands on a Linux instance in production. And as you can imagine, it was pretty risky. And for a fast-growing company like Amazon, who was trying to innovate and make the customer happy, it was really unacceptable. So the organization had to make a few essential changes to fix that. One was architectural and the other one organizational. So as I mentioned, first we broke the monolith into service-oriented architecture, what is called today microservice. The few things that were really important during this refactoring was services created had to be very small, they had to be focused, single purpose, and connected via HTTP API. And that's very important because it created a highly decoupled architecture with services defined by HTTP API. So as long as the API didn't change, the team operating that service could innovate faster and without worrying about breaking everybody else. Then have you heard about the Conways Law? It was named after Melvin Conway in 1967, and the law tells us that the software interface structure of systems is often a mirror of the organization that releases it. And this is beautiful because then you can think about how your organization is organized and see the impact on the software deployment, the development process. So after tearing down the monolith, we also tore down our organization. And the top-down hierarchical organization was broken into a small team, what I mentioned earlier called two pizza team. They were given full autonomy, so working with internal and external customers, setting their own roadmap, agreeing on service specification, writing code, running tests, deploying to production, and even operation. So this change made things go a lot better, but it was not great yet. And what do you do when things aren't great? Well, you measure, you collect data, and of course, you have to listen to anecdotes. So there are two leadership principles that are, in my opinion, very important to developing a mindset of collecting data and especially understanding it before starting any work. And these LPs are insist on the highest standards and diving deep. So insist on higher standard means that having relentlessly high standard, continuously raising the bar and delivering high quality products, service and processes. Dive deep means diving deep into the issue at hand and making sure that you know all the details before taking any decision. So clearly all these is very vital for an organization that is focused on operational excellence. And those cultural traits led Amazon to measure its software development process. Remember, things were good, but not great. It discovered that it was taking an average of 16 days from code check-in to being deployed in production. It also found that operational people spend most time doing manual work, including emails, ticketing, and so forth. In other words, people were spending most of their time waiting. And that was a problem to be solved. And it was solved using automation. It's also when you realize that culture and tools go hand in hand. Without diving deep on the problems, without wanting to raise the bar, the next transformation would certainly have never happened, and Amazon wouldn't be what it is today. So to avoid developers waiting time running build commands, Amazon created a centralized hosted build system called Brazil. The main functions of Brazil was to compile, to version check, and to do dependency management. And it was focused on build reproducibility. Again, consistency was key. So Brazil executes a series of commands to generate artifacts that then can be stored and deployed. And to deploy this artifact, Apollo was created. So Apollo was developed to reliably deploy a specific set of software artifacts across a fleet of instances. And this was really new back then. Developers defined the process for a single host, and Apollo coordinated that update across an entire fleet of hosts. It was a big deal. The developers could simply push deploy their application to development, staging, and production environment. No logging to the host, no run command, nothing. All the deployment was automated, and it removed the bottleneck and enabled team to deliver software feature faster and make customer happier. If you want to read about more about Apollo, I've included a link to Werner Vogel's blog in the slide. However, automated deployments can't solve everything. So deployments are in fact part of the larger picture. They are part of a workflow that starts the instant a developer commits code to a repository and that ends when that change makes it to production. So we built a tool called Pipeline that models that workflow, and it models the path a code takes from check-in to production. Pipeline is a continuous deployment system that allows developers to create fully automated deployment from the moment the code is check-in, that it passes these tests to the production without manual intervention. Of course, not everything can always be automated, but still Pipeline lets you automate the things you're comfortable with. But most importantly, it codifies the steps required between checking code to having it running in production. Pipeline is also where verification steps happen, whether it's testing, compliance verification, security review, auditing, or even explicit approval. A pipeline consists of the number of different stages. For example, you have here a build package that is creating into a version set, then it flows into a gamma stage, then a one box production, and then an entire full production stage. Each arrow is a promotion step that serves as a validation gate before the release goes to the next stage. Pipeline started as a pilot at Amazon and with a very small number of teams. And by the end of the pilot, one of the team achieved 90% reduction in time it took from code checking to being released to production. 90% reduction. So as the other teams at Amazon saw the success of this team, they of course naturally migrated to using pipeline. And teams that had custom-made releases converged into a standardized method used by everyone. And again, standardization is very important here. So this migration to pipeline allowed teams to also find new ways to innovate and simplify the whole delivery process. And finally, it's also worth mentioning that the above tool chain here is highly integrated with common logging and monitoring system. Brazil and Apollo brought a lot of goodness to the organization and to the customers, of course. But it's also brought a lot of software changes. And by the end of 2018, we were deploying hundreds of millions of deployments a year. More importantly, while it was speeding the software delivery pipeline, the broad adoptions of this tool reduced the risk of deployment failure because those tools, they drove consistency, standardization, and simplification of the release process. And indeed, the development and adoption of those tools resulted in fewer defects being launched into production. And fewer defects in production means happier customers. And that, in my opinion, this is the essence of operational excellence. So if your delivery pipeline needs improvement, Brazil, Apollo, and Pipeline have inspired a set of tools from AWS. It's called the AWS Codestar series of developer tool. And you can use such tools like Code Commit, Code Build, Code Deploy, Code Pipeline, and Codestar today in your organization to speed up your delivery process. So let's talk about the third important aspect of operational excellence, and that's processes. So to help you understand the importance of processes, I want to share one of my favorite stories from Jeff Bezos, the CEO of Amazon. It starts with our customer connection training. So the customer connection training is available for every Amazonian. It's a training that's put in place to support our mission to be the Earth's most customer-centric company in the world. And it's also a training that is used to help make the connection between our work and the customers. So the story goes as follows. Several years ago, Jeff took part in this customer connection training, and he was together with a very experienced customer service representative. And he took a phone call from one of the customers to respond to a complaint. So as soon as the customer representative pulled out the list of orders from the customer that was calling, she looked at Jeff and whispered to his ear that the customer was probably going to be returning one of the particular item on the list, a table, and because she believed it was going to be damaged and scratched. So as you can imagine, Jeff kind of was a little shocked and baffled by this prediction. And indeed, the customer actually wanted to return the table because it was damaged and scratched. So after the phone call, Jeff asked the customer representative how she knew in advance that the table was going to be damaged. And she answered, well, oh, those tables always come back. They're always damaged and they are not packaged well. So that the surface of the table always gets scratched. And well, Jeff scratched his head in return and wondering how it was possible that something so easy was happening. So he did what every CEO wanting to solve a problem does. He went to the leadership team, the customer service leadership team, and asked them to do a better job and to especially close the loop between the customer service and the fulfillment center that was packaging those items. Well, can you guess what happened? Well, nothing really happened. And there's a very good reason for that, because Jeff was asking for good intention. Yeah, and to give you an example of good intention, think about yourself in the morning. Do you wake up in the morning and tell yourself, today I'm going to go to work and do a terrible job? So you probably don't do it. Most of us want to do well. We all have good intention, and so did everyone in the customer service department. So the question is then, how do you do that? How do you solve such an issue if good intentions don't work? Well, and the answer is mechanism, or a complete process. And mechanisms are a lot better at fixing problems than good intention. And there is a happy ending to the scratch table story. But first, I have to go back to 1902 to a company called Toyota. And if you're wondering why on the slide there's a silk waving loom and what it has to do with Toyota, it's because the company you know today that makes cars started back in the day as a silk weaving company. And Toyota operated silk weaving looms to create silk for geishas. And geishas, they wouldn't accept any silk that had any flaw. They had a very, very high standard. So in 1902, Toyota-san, the founder of Toyota, created a very small mechanism that would go on the loom and that would immediately stop the loom if any issues was found on the silk thread. That little idea started something very essential, very powerful philosophy at Toyota. The philosophy that Toyota would never allow any defect that they know about to go down the manufacturing line. And of course, if you think about this for a second, it sounds like an act of faith more than the philosophy. Rather than trying to make it complicated, Toyota simply decided not to let any defect they found go down the manufacturing line, regardless of the cost that it would be associated with. And Toyota had for some time now across the manufacturing lines, or the assembly line, some lines, as you can see on the slides, pointed in red with the red arrows. So you pull the cord and it stops the production line. Yeah, those cords are called the undone cord. And they are very often mistakenly identified as a safety equipment. But they are not. At Toyota, they are there to prevent any defect, even small ones, from moving down the manufacturing line. Any employee at Toyota is fully empowered and expected to pull the cord if they see any defects. Immediately after the undone cord is pulled, the team leader will personally go and see the problematic workstation. The first thing that they will do is to thank the operator for stopping defect from making it down the manufacturing line. And as you can imagine, this undone cord approach, when it was first discovered by Western manufacturing companies, was pretty terrifying. How could you let anyone in the manufacturing floor decide to stop a multi-million-dollar manufacturing line? It's not the kind of freedom senior executive in Western companies like to give away. But at Toyota, it was a real mechanism. The mechanism of empowering everyone in the company to stop defect and make sure that they are fixed before they reach customers. The critical part here is the association of the tool, the undone cord, with a particular behavior and a specific culture. If you want to learn more about that undone code, I strongly recommend to read the Toyota Kata book from Mike Rother. So back to the scratch table story. Amazon took that very simple but powerful idea from Toyota and built an undone customer service. The tool that lets any customer service representative stop the line, which means removing any product from the Amazon retail website in minutes if any defect is detected. And then today it's still up and running, and it's been very successful. You can see here one of the undone code at work, and the item is in preview because the undone code was pulled by a representative. So Amazon has built multiple versions of this undone code process. Jeff Bezos shared one of them in his letter, in his 2012 shareholder letter. It's called the undone automatic refund program. And it was implemented to address customer trust, especially when the delivery of videos was below our standard. The idea behind that program was not to drive purchase behavior, but really to address customer satisfaction. And this is key because today the program continues to receive very positive feedback from customers in the forums and in the press. So where do I want to go now? Well, if you see yourself frustrated by a recurring problem and you catch yourself asking people for good intention, so asking people to try harder, well, remember that you're actually not asking for change. Remember that good intentions already exist. They're already there. So that means what you really need to do is do something else. So, and this something else is having a mechanism. So a mechanism is a complex process, right? It's made up of 3 steps: the tools, the adoption of that tool, and of course the auditing part. So imagine for a second that you build a tool. Well, that tool is useless if you don't have a training program and a way to drive its adoption. And it's also essential that you have some kind of continuous audit mechanism that ensures that tool is operating as designed. I've worked in many companies that had tools and no one used, and some of the tools were great. And this is exactly the problem. There was no adoption framework. So coming back to operational excellence, one mechanism that Amazon developed over the years is called the corrections of errors. It's a process that we use to reflect on problems, maybe sudden loss of redundancy, failed generator, failed software deployment. It's a document that we use to identify the problems and avoid it from happening in the future. So it's a mechanism that from which we learn our mistakes, and whether it's a problem in the tools, in the process, but also the organization. As I said, tools, process, organization. So we use this COE mechanism to identify the contributing factors to failures, and especially to drive continuous improvement. It's not new at Amazon. I've seen COEs from 1999, but it's become more productive over the years. So, sorry, I didn't click on this slide. There are 5 main sections of a COE. First is what happened, right? What data do you have to support your statement, your analysis? What's the impact on the customer? What are the contributing factors? Remember, you need to look at the tools, the culture, and the processes. And then what did you learn? And how will you prevent it from happening in the future? And this is very important. You don't want to identify something and then not figuring out how you want to prevent it from the future. And this is the continuous improvement part. So if you want to learn more about the COE, because I have limited time, you should definitely go and check the great talk from reInvent 2019 from Becky Wise, senior engineer at AWS, and there's a link on the deck. So now let me touch two leadership principles that are very important for a COE process. So earn trust and dive deep. The key to have a very successful COE process is to be open and transparent about what went wrong. Right? That means that you have to listen carefully and also be sometimes vocally self-critical and admit errors. And you also have to dive deep in the issues and find all the nitty-gritties that are important to understand. It's really key to the COE process and operational excellence in general. And that's a part that is often quite hard in an environment that doesn't embrace or encourage such behavior. And it's very common to see environments that try to find people as the cause for failures. So don't stop at people, don't blame, trying to really be open and find the right way to solve an issue. So to make the COE mechanism complete, you have to have some sort of continuous inspection. You remember this auditing in the mechanism. So we do this auditing in the form of weekly operational metrics review meetings. So this is a place where individual service teams gather and review some of the metrics in front of the senior leadership. So all the service teams are expected to be ready and to present their operational metrics. So that means that they have to have their fingers on the pulse, right? And really intimately know what the service are doing and how they're performing. The good thing is they never know when they present. Actually, the team selected to present is chosen randomly using a wheel. This is the wheel of fortune. When selected, they have 15 minutes to dive deep on the service metric, and the learnings are often applied across different teams. Many are actually added to the well-architected framework. They make it to the customers in forms of white papers or tools or even AWS services. The COE process, so with this COE process and the weekly operational metric review, you'd think that we've ruled out good intentions and that problem found in one team would immediately make it to the other teams. But you'd be wrong, because if you do that, you again ask for good intentions. So instead, you need to have another mechanism, a mechanism to enforce continuous improvement. Remember, continuous improvement was the goal. So instead of asking for good intention, we built yet a new tool called Policy Engine. And Policy Engine scans the infrastructure, scans the environment for configurations and things like this. And it does so to find risks and potential cost saving opportunities. So policies, they are created from the problem found and identified during the COE process, and the issues that can be codified. So the tool is extensible, so when the new problem are identified, very easily a new policy can be added and created into the tools. And that makes it to all the team. And more importantly, the policy engine as a dashboard that represents the holistic view of all the teams and how they perform in terms of identified risk and saving opportunities. And that really helped the organization continuously improve services and operate as cost effective as possible. And again, it maintains the flywheel in motion. So these mechanisms, they have inspired some of my favorite AWS tools. And I'm talking about AWS Config, AWS Trusted Advisor, and of course the well-architected tool. So strongly suggest that you have a look at those tools. Finally, to conclude, remember that it really takes three interconnecting elements to operate the technology we build. First, you need to have an operational focused culture. That's really critical. Then you need to have rich sets of tools. And of course, you need to have the right supporting processes. And finally, really don't forget that good intention don't work. And instead, focus on mechanisms, because that's the key to everything. On that note, we also know that there might be better ways to do operational excellence, but I wanted to present the one that we have chosen. But we humbly remain open to feedback and discussion. So if you have any, feel free to send us your feedback. Thank you very much. And here are on the slides are my contact details. So feel free to follow me on Twitter and on my blogs. And of course, you can send me messages if you want to talk about this. And all these slides and story, they made it to the blogs as well. So thank you very much. Have a good end of the conference. Bye-bye.